Hello and welcome to the next video in the Unix induction series. What we're going to be looking at now is process control. So what I'm going to do is I'm going to open up Terminal, the best application ever, make it full screen and zoom in just like always. Now the first command I'm going to run is known as the PS command. PS will show you a list of running processes. At this point you might be wondering, what is a process? Every application running in Unix and Linux is given what's known as a process ID, and that's what we're going to be looking at next. So the first command I'm going to run is PS. I'm going to add an option here, -u. And just so you know what the option does, I'm going to open up Terminal, again, man PS. I'm going to scroll down to find the right flag, and just give me a sec so I can find it for you. Here we go, -u, and then user list. So what this does here, or --user, what we can see here is it allows us to show processes currently associated with a user. As there are a lot of processes running on a system, instead of giving you a big long list to sort through, I only want to work with the current processes associated with the user on this system. So that's why what the -u flag does. So what we're going to do now is PS -u and then the username. So as we can see here, the user I'm currently logged in as is induction. So I'm going to type induction here. What we'll get is a nice long list of every process that is currently running on the system. On the left here, we have the process ID. Every process has a unique ID. So you'll never have a process that has the same ID. Each process will have its own unique separate ID. Some processes will share the same command name, i.e. the same command can be running multiple times, multiple instances of the same application, but each of those will have a different process ID. So just to reiterate, on the left here, process ID, on the right here, command name. So if we scroll through, we can see various commands. Some you may recognize, a lot of these will seem unfamiliar at first. A lot of these are associated with the operating system. Here we can see even the command PS, which I'm running up the top here, is given a process ID. And the screen recording software I'm using to record these videos has its own process ID, as well as the desktop environment and a few others, the audio server. These are all given process IDs. So what we're going to be looking at now is how to stop processes that maybe run out of control. For example, let's say you're working on a C program and you have a while loop that runs infinitely. You may want to stop that by using process control. So what I'm going to do is I'm just going to make this terminal move to one side of my screen, just so I can show you an example of working with different processes. So what I'm going to do is I'm going to clear my screen and then I'm going to open up an application for testing. This is going to serve as our example application. I'm going to use gedit, and that's going to be one of the editors. It's a GUI editor, and I'm going to use and on the end. All and will do is stop it from locking the terminal and allow me to work with processes. So gedit, what we'll see is I've opened up this application here. So pretty standard, just the same as going Alt F2 and running it that way. But what we're given here on the left is the process ID, and what we're seeing here on the right is the process. If I was to run PS-u and then the user, induction, what we'll see in this list down the bottom is we've got gedit. So what we can do next is if we wish to stop gedit for any reason, let's say gedit has become unresponsive and we wish to close it, we can use the kill command. Now kill, as it sounds, will stop an application. So let's do that now. Kill. So kill by itself requires just a PID, and the PID, again as mentioned before, is listed on the far left column when using the PS command. Every process again will have a unique PID, so you won't kill every instance of gedit, you will simply just kill the one that's intended, again the one that matches the PID. So 6563, enter. And as we can see, gedit is now gone, and if we were to run the PS command again, we can see that gedit has been terminated and that there is no longer a process ID with gedit. Again, I'll do that one more time, and I'll run it using the Alt F2 method, PS-u induction. Again, gedit is here. What I'll do, oops, I can't click on it. Here we go, gedit's here. I'll kill it again, 6570. And what we can see is now gedit is gone. So that's one example, and that will kill by process ID. It is best practice to kill by process ID simply because of the fact that every process has a unique ID and it won't kill all instances of that process, just that specific instance. So now what we're going to look at is a different way to kill processes. So what I'm going to do is I'm going to open up gedit, and as we can see here, it's running on the right, and I'm going to run this command again just to show you. And this time it's going to be a little bit different. We're not going to use the PID on the far left. we're going to kill by process name on the right. Keep in mind there are lots of different scenarios when using computers, and sometimes you'll have the process ID, sometimes you'll simply have the process name. The great thing about Unix and Linux is there's lots of different ways to do things, so you'll find there's more than one way to kill a process. In this example, we can kill by PID or we can kill by process name. To kill by process name, we can use something known as pkill. With pkill, instead of specifying the PID, such as 6577, I can specify the name gedit. Now when I run this, it will kill all instances of gedit. Keep in mind, this will kill any application that is named gedit. If you're running as admin or administrative user, you will kill all instances of gedit on the system, even ones that do not belong to your user. So be very careful when using pkill, as sometimes it can kill applications that weren't intended to be killed. So again, it is recommended to use kill by PID instead of killing by process name. But you never know, you might find that you need to kill all applications running, like for example, all tabs opened by Google Chrome, all browsers that are currently open, all terminals that are currently open. Again, the scenarios may change. We're simply giving you the resources to be able to kill by both process ID using kill space PID, or pkill, and then the process name. Two different ways to do it, again to suit multiple scenarios. And there is now one final way I want to show you to kill applications. And that's what I'm going to do now. I'm going to open up gedit again, just to have an example. This final way is a bit of a quicker way when you want to kill an application and you don't really feel like thinking. So what we can do here is use xkill. Now xkill will kill basically X applications. In Unix or Linux, an X application is a GUI application. So what we're saying here is xkill. Now what you'll notice is some text comes up on the screen. Select the window whose client you wish to kill. Now, I'm not going to highlight the text because as soon as I select terminal, it will kill terminal. Instead, you'll notice that my cursor has become an X. And now what I'm going to do is go over the application I no longer wish to have active. Once I click on it, whichever window I click on next will be killed and the process will be stopped. So just as a demonstration, I'm going to use that on gedit. Click. And as we can see here, xkill, killing the creator of resource, blah, blah, blah. So what we've been able to do, and I'm just going to go through them again, just real quick, is we've got the ps command, which shows us process information. So using the ps command, using the manual plus the ps command, we can find different ways to view lots of information. For example, we can view all processes. We can view, for example, select all processes except both session leaders. And some are a bit more complex, but you'll find there are lots of options to show you different processes. And the ps command, when used with -u and induction, will give us a list of all processes associated with the user, PID on the left, process name on the right, and then we've got our different options to kill. So we've got kill by itself, kill space PID, and again PID on the left here. So for example, if I wish to kill bash, I can do kill space 6498. Then we have pkill, which is kill by process name, listed on the right here. For example, if I wish to kill bash, pkill space bash. And then we have xkill. Xkill kills a GUI application that is currently running. I can run that and then click on the application. That's 3 different methods to kill a unresponsive or even a responsive process. Now, one other command that's quite useful is the top command. Now, top is kind of like seeing the task manager in Windows. Top will show you which processes are currently using the most CPU. So as you may notice with ps command, it doesn't necessarily give you usage information. It more shows you simple information about which processes are running. With the top command, we can see in sort of an interactive which one is using the most CPU. So what we can see in this one is that a program called Simple Screen Recorder, which is what I'm currently used to record these videos, is using the most CPU. And to me, that sounds about right. So I'm not going to kill at the moment, otherwise this video will stop. But as you can see, using this, we've still got the useful information, of PID on the far left and command on the far right. So you can either use top or ps to get information about running processes, then use kill or pkill or xkill to stop the process. This gives you great control over any applications that are running. And this will come in handy later on, especially when you start programming and things are bound to go wrong. So it's good to have the ability to stop unresponsive processes. So I hope you've enjoyed this video. This has been Process Control, and I'll hopefully see you in the next one.